Hi, I'm Chris Maddock, designer of the Harmony House.
Hi, I'm Scott. I'm a principal of JRS Engineering, and we're the building envelope consultants for Harmony House. We provide a number of services that provide value to our clients. Let me introduce you to Cory, who's the project manager.
Cory, the Harmony House guys are here.
Hi, I'm Cory. I am the project manager for the Harmony House for JRS, as Scott and Chris have mentioned. We will be doing the building envelope design and review for the project. We basically got involved in doing the details. Then we do, during construction, we'll do the field review to make sure it's implemented and put in as we designed, and basically done through mock-ups and various ways, shop drawing reviews and testing on site of the various assemblies. We got involved through Chris, and we really saw the value of the project to the community, to homeowners, industry at large. There's a lot of opportunity here with these types of projects, a low energy or even zero energy project. The value to them as well as to us is learning this stuff and making sure that our expertise can be implemented and given to the various people involved and the client. We like to get involved early in our projects. Essentially, we provide a roadmap throughout the whole process, from design right through construction, to make it as efficient from an envelope perspective, whether it's the air barrier or the vapor barrier. The thermal value is quite high on this job, and that's, again, it allows us to do that. So the first thing we do is we get together with Chris in a design meeting, and we go through that, and we go through some assemblies, we go through the materials and what we feel is most appropriate and what works with what he has designed. We'll go back to the office, we'll take that design and we'll take his drawings, and we're able to basically produce the details, actually how it should be made on site, how it should be constructed, and we put that into our AutoCAD drawings, and which gets inserted into the building permit set and coordinated with Chris. During construction, we're also doing window testing. We'll basically make a little storm on the window, make sure it doesn't leak, and if there is something that does come up, now's the time, and we'll see that before it happens. We make changes if we need to. The other things actually done on this project, which aren't always typical, but since it's a sort of a high-tech building, it's a very airtight, very thermally efficient. We went and looked using modeling as hydrothermal model to find out if it's so tight and how everyone lives in the building. You have to make sure that the assemblies will work in our climate. So you use some computer modeling, model the assembly, and we're able to determine the moisture in the assemblies, and you can see where we might have an issue or not, if we need to change anything. So that's one of the other things we did on this project, which was quite interesting and a lot of fun to do as well. You learn quite a few different things when you model it versus what your experience tells you. So
I'm really interested in seeing those computer models. So
well, I can take you right now. We can have a talk to the guys that actually did those computer models.
Just as a good drainage system takes water off the roof and away from the foundation, proper ventilation takes excess moisture out of the home before it can cause damage. Energy Star rated bathroom and kitchen fans are an excellent way to remove moisture from where it originates, helping to keep your home free of mold and mildew. Look for the Energy Star label when purchasing any home appliance.
Sure.
No, Dave.
So
Dave, yeah, I don't know where Dave went. I'm everywhere though.
This is Andrew Shaw.
We're designing ceilings over here and roofs over here.
Yeah. So, I don't know if we want to introduce.
What do we get to see? Show us something.
Well, this is Andrew Shaw.
Yeah, this is Andrew.
Andrew's, a young engineer with 4 years of engineering experience, and I'd say mining, but it's mining but designing furnaces.
Yeah.
So he's a whiz at thermal calcs, which we use for energy calcs on walls. And you'll probably see a little of that later when he shows you some therm modeling.
And the hydrothermal modeling, which is what I mentioned for the project for Harmony House. He did that as well.
So currently he's working on some structural detailing for roofing. So mainly we design, when you talk about structural detailing for wood or for roofing or cladding, we're generally talking about wind loads and wind uplift. So in this case we're talking about how many fasteners we need per 4x8 sheet of insulation, so that in a windstorm the roof doesn't fly off, because that has dire consequences typically.
I can see that as a valuable thing.
Yeah, it's not a light thing when it falls off the roof.
No.
It doesn't happen often, but it happens. A windstorm will kick up a couple of roofs out of the lower mainland and put them in the parking lots.
Hey Dave, the Harmony guys were here. Harmony guys were here shooting the documentary, and I wanted to show them the hydrothermal model.
Oh, great. It's on Andrew's computer, so maybe
Okay.
we'll just get him to pull it up. Okay. So this is the 1D model. It just basically shows you the analysis as in real time. So I'll just play that. So basically you can see in the model, essentially it's charting the different temperatures as you go up and down, and as well it's showing you the water content over time. The analysis was over a period of several years, so that we could just make sure that we model the actual assembly as it will perform in real life. So we got really good results, and we're happy with kind of the direction of the modeling. And yeah,
This was done for the roof, right?
yeah, this was done for the roof, essentially, for the roof assembly on Harmony House.
And so the red's showing us the temperature, and the green will be showing us the moisture content.
Yeah, essentially over time, when you're winter, spring, summer, it's showing you the temperature changes, so we can just monitor what the parameters are to make sure that our modeling is accurate, that we're not going in temperature ranges that are beyond what we would actually expect. And then we can observe essentially how that correlates to the water content, to make sure that the water content of moisture sensitive components like the wood sheathing in the roof is at a level that we're happy with and comfortable with.
I remember what initially we found was essentially that it looked as though that we were going to have to put in some more vapor tight materials, because it was showing that the moisture content in the plywood was getting to basically those thresholds we don't want it to be at. So we're able to, again, analyze what products are going in, what materials, and figure out what we need to do. So this is the animation, right? But I mean, essentially we just use the straight numbers when we're doing it.
No, this is just a visual, so that it helps give you a better intuitive sense of what's actually happening over time. But that's just the output essentially of the software.
Thanks, Dave. Andrew.
Thank you, Cory. Anything else we can do to help? We're always here.
Good.
Always. When it comes to computer modeling, we're always here.
Okay, so that was great. Why don't we, I'll show you some of the AutoCAD that we do, or producing the details on the drawings. Harmony House, obviously we worked with Chris to get the package basically ready for permit and for construction purposes. We've got all kinds of drawings. Do you have any of the Harmony House up here?
Do you know what the job number is?
Yeah, 09982.
Base of wall. There's typical base of wall detail.
Not so typical with
with
the insulated walls, but
yeah, exactly. But yeah, I guess we took Chris's elevations, went through them, and decided which details we needed to do, and just did them up.
make sure they work for our waterproofing assemblies and what we need. So yeah, thanks, Rob. Something that we find is very important to us and basically benefiting everyone else if we can get these types of projects that are low energy or zero energy out into the marketplace. So we're actually providing our services as a pro bono for the project because we just feel it's the right thing to do.
Hi, I'm Bob Douglas with another often misunderstood building term, rain screen. A rain screen is an exterior wall design strategy that has two primary functional elements. The first is that it prevents rain penetration by deflecting most of the rainwater at the outside face of the cladding, or exterior wall finish. The second element is the drainage and ventilation cavity behind the cladding. This allows any water that gets through to be drained back to the outside or dried by natural air circulation. Many regions now require this to be part of their building code.
Hi, my name is George Pinch. I'm the chairman of the Greater Vancouver Home Builders Technical Committee.
And my name is David Hill. We come here as a committee. We meet 10 times a year. The main objective is to further all of our knowledge. We have builders, architects, designers, sub-trades in our meeting. And we have meeting every month, and this was one of our site tours to give us all an opportunity to learn what Arthur and Chris are doing to advance the art of home building and making a house healthier and more efficient. I think what we learned today is how you can build a good foundation that's dry, that's warm, and do it practically. Concrete with insulated concrete forms. How the wall is going to be built with 2x6 walls with very, very high-tech insulation between them. But we're trying to, or Arthur's trying to, and Chris are trying to show here how you can build a house that looks like an ordinary house, but really performs well with half or a third or quarter of the heating requirements that would be of an ordinary, similar-looking house.
We have to keep learning. There's no excuse not to keep on educating yourself. And we have to keep up with the times, and we have to keep ahead of the economy, and if we're going to keep having a high standard of living, we're going to have to use what we have more wisely and more efficiently.
Certainly believe in that. We cannot afford to continue to be as wasteful as we have in the past, and this is just one small example of building a house, a lifestyle that's a little less wasteful, a little bit more responsible.